All right. So let's talk about equivalent fractions really quickly. We talked about them a little bit earlier, but as a reminder, remember the fraction a over b is the solution to the equation bx equals a. And we can multiply both sides of this equation by anything we like, except 0. You shouldn't multiply by 0 because then you just get 0 equals 0, which is true, but it kind of devoids all meaning from this equation. So this gives us the equation bcx equals ac. And the solution to that equation is a times c over b times c. So what does that tell me? These are the same equation. They have the same solution, since all I did was multiply both sides of this equation by c. So this tells me that the fractions a over b and ac over bc are equal. We'll call them equivalent fractions. As long as c isn't 0, of course. So you can multiply any fraction you like by top and bottom by any number, and that will give you an equivalent fraction. So just a couple of examples to see that. So if I have something like negative 3 over 4, negative 3/4, I can multiply top and bottom by 5, and I get the equivalent fraction, negative 15 over 20. And you can kind of work backwards as well. If you have a numerator and denominator that have a common factor, well, you can divide top and bottom by that common factor. Say negative 7 here. So negative 14 divided by negative 7 is 2. And negative 21 divided by negative 7 is 3. So we get that negative 14 over negative 21 is equivalent to the fraction 2/3. In some sense, we can say they describe the same quantity. They're just synonyms of each other. And you can see it backwards. So if I take 2/3 and I multiply top and bottom by 7, of course I'm going to end up with negative 14 over negative 21. Now, let's see what this looks like in terms of our model. So imagine we have quarters. So we broke our unit up into 4 equal pieces, and let's say we have 3 of them. So I'll shade in 3 of them. 1, 2, 3. So we have 3 quarters. Now nothing's stopping us from breaking this up even more. So maybe rather than breaking it up just into quarters, so I broke it up into 4 equal pieces vertically, I'm going to break it up into 3 equal pieces horizontally. So let's go ahead and do that. Oh, that's not what I want. I want to do it with the pen. Here we go. There we go. So we did that. Well, now what did we do? Well, we tripled the number of equal pieces that make up 1 unit, but we've also tripled the number of these pieces that we have. So the fraction 3/4 is equivalent to 9/12. So I'm just breaking up each quarter into 3 equal pieces, giving us 12 in total. Which means if we have 3 of these quarters, well, how many 12ths do we have? Well, we just triple it. We have 9/12. All right, so let's talk about comparing fractions. So let's look at the first question here, A. Which is larger, 3/7 or 6/7? Well, this one is pretty easy. We have 7ths are the size of the pieces that we have. The left number has 3 of these. The right number has 6 of these. Obviously, 6/7 is more than 3/7. So we can put this symbol here. 6/7 is greater than 3/7. Okay. What about something along the lines of 2/3 and 1/6? So now, it's not quite as obvious. It's still not too bad. But here, 3 pieces make up a unit. Here, 6 pieces make up a unit. So we can't just look at the numerators and say, oh, we have 2 pieces here and 1 piece here, so obviously 2 is more than 1, so this is greater. Obviously, we can't do that because the sizes of the pieces are different. What we need to do is we need to ensure that our fractions are broken up into pieces where they have the same size. So we can use the idea of equivalent fractions. So here we can see if we multiply top and bottom by 2, well, now we get sixths in both numbers. We have 4/6 and 1/6. So which one is bigger? Well, now that we have the same denominator, it's quite easy. Obviously, 4/6 is greater than 1/6. Okay, now let's look at the idea of the last one, 4/5 and 10/13ths. So here, what we can do, this is a really good idea, and you can always do this to get 2 fractions with an equivalent denominator. Just multiply top and bottom of one fraction by the other denominator. So I'm going to multiply top and bottom of my left fraction by 13 and top and bottom of my right fraction by 5. That will give me a denominator of 5 times 13 for both of these guys. So this gives me, well, 4 times 13, you can check, is 52. And 5 times 13 is 65, so this is 52 over 65. And 10 over 13 is 5 times 10 is 50. 13 times 5 is, of course, the same, 65. And now it's obvious. So 52/65 is greater than 50/65. So kind of the rule here, I guess, is get equivalent fractions with a common denominator. Then compare numerators. And in some sense, there is a shortcut here. Because what are we really doing? If we know the denominators are going to be the same, all we need to do is take each numerator and multiply it by the opposite denominator and compare those. So, kind of the shortcut here. So, A over B is less than C over D exactly when AD is less than BC. We're just comparing A times D and B times C. And obviously there's nothing special about less than. We could do greater than as well, and the same logic will hold. So you can view it like this as well. When we start dealing with fractions, especially when we're going to add or subtract them, we want kind of as small numbers as possible just to make our lives easy. So an important thing is getting a least common denominator. So have a think about if you could determine finding the least common denominator for these two fractions, 31 over 48 and 61 over 120. I will say that you should be able to use something that we talked about in a previous video that has a very similar name here. Because think about what a common denominator for these would be in terms of the idea of it. So pause the video now and see if you can figure that out. Okay, so now that you're back, the idea is all equivalent fractions to these, or at least ones where the denominators get bigger, are going to be multiples of 48 and 120. And we want a least common multiple of these. So that's what we need to figure out first. So the solution, we need to figure out the least common multiple of 48 and 120. So let's do it. 48, you can write this, if you like, as 2 to the 4 times 3, and you can check that via a tree diagram if you like. And 120 can be written as 2 to the 3 times 3 times 5. Okay, so remember the least common multiple, take your prime factorizations and take the greatest number of each of the primes for your least common multiple. Here we have 4 2's, here we have 3 2's, so we're going to take the greatest, which is 4 2's. We have 1 3, and we have 1 5. Since here we have 0 5's, here we have 1 5. 1 5 is greater than 0 5's. So our least common multiple is 2 to the 4 times 3 times 5, which is, of course, 240. And the reason I did that so quickly, I noticed it's just an extra 2 from 120. So I multiplied 120 by 2, and I got 240. So that's our least common denominator, is 240. So let's come up with equivalent fractions here. We need to figure out what to multiply top and bottom by to get equivalent fractions where the denominator is 240. Well, we just talked about 120. That was 2. Because you can see that if we take 3 2's, 1 3 and 1 5, all that's left over is 1 2. So if we multiply top and bottom by that 1 2, we'll get our denominator of 240, and our numerator, in this case, will be 122. And 48, well, what are we missing? We're just missing the 5. So here we have 2 to the 4 times 3, so all that's missing is the 5. So we'll multiply top and bottom by 5 to get the equivalent fraction. So the equivalent fractions are 155 over 240 and 122 over 240. All right, so let's do another one that involves fractions and simplifying fractions, but kind of from the other direction. So let's express the following fraction, 1,617 over 924 in lowest terms. So what does that mean? Lowest terms mean that the numerator and denominator have no common factors. So any common factors that the original numerator and denominator have, we're going to divide out by them. So, again, thinking about things we've learned previously, pause the video now and think if you can come up with a plan for solving this. Okay, so what we need to do is we need to figure out the common factors of 1,617 and 924, but not all of them. What we need to divide by is the greatest common factor. That will put this fraction in lowest terms. If we divide by the greatest common factor, then there's no other factors left between the numerator and denominator. They're all factored out. So we need to find the greatest common divisor of 1,617 and 924. Okay, thinking about this, pause the video now and see if you can find this. All right. So there are two ways of going here. I will say you could do a tree factorization for both numbers, but that might take a while. If you're just looking for the greatest common divisor of two numbers, the Euclidean algorithm that we learned is probably a little bit easier to do. So let's go ahead and do that. We'll divide the smaller one into the bigger one, 924 into 1617. It goes once. We subtract 3, 5, 11. 11 minus 2 is 9. That's 15. 15 minus 9 is 6. So we need the greatest common divisor of, we can think of it as 924 and 693 now. Okay, and we keep going. 693 into 924 goes exactly once. We subtract 693, and we're going to get 231. So now we need the greatest common divisor of 693 and 231. If you're struggling to see what's going on here, I suggest that you pause this video and go back to the previous video where we talked about the Euclidean algorithm and refresh yourself on that method. So let's keep going. 693 into, or sorry, other way around, my mistake. 231 into 693. Try 3 times. 3, 9, 6. Oh, look at this. This is great. We get a remainder of 0. So the greatest common divisor of 231 and 0 is, of course, 231. So there we go. We found the greatest common divisor. And not that you need it, but its prime factorization is 2. Sorry, it's not 2, it's 3. 3 times 7 times 11. You can check that by a tree diagram or whatever. So we found the greatest common divisor. So we'll just divide the numerator and denominator by 231. And you can check, we get 1,617 divided by 231 is 7. And 924 divided by 231, you can check, is indeed 4. So this fraction simplifies to 7 over 4. Again, 7 over 4 and 1,617 over 924, they are equivalent fractions, and they stand for the same quantity. They represent the same quantity, just written differently. You can think of them, if you like, as synonyms for that same quantity.